Okay, ladies and gentlemen, good afternoon. Now we go to the question number 1. A force of 50 Newton act on the range of P as shown in diagram. So here, this means that this is a nut and this will be the handle. The handle with the length at the end, so it will be 0.25 meter. So first, the force applied. That means that the user hold the handle at the center or at a distance of 0.15 meter from the center of the nut. So A, calculate the torque on the board. So what is the torque on the board? How much of the F? So first we use what is the angle? The angle is a straight line, right? So this means that it will be already in 90 degree F and the distance already in 90 degree perpendicular to each other. So this means that we use the basic formula. The formula should be equal to torque equal to F RF sin delta. Because here is a straight line, so this means that it will be equal to R. R will be a distance of 0.15 meter times with the F is 50 Newton. Then the distance will be sin 90 degree or equal to 1. At the end, we get that it will be 7.5 Newton, 7.5 Newton meter. So this will be the torque. Question number 2, if the 50 Newton force now at a point at Q, what is the maximum torque? If the question said that now, if the force is at on Q, this point, that means that with F equal to 50 Newton. So same thing, torque. Or the symbol torque equal to RF sin delta. So this means that what is the distance? Distance will be 0.25 times with the F50 sin 90 degree. So at the end, we get that 50 times 0.25, it will be 12.5 Newton meter. Okay, let's go to the next question. Question number 2. A student holds a lot of 20 Newton in her hand. So 20 Newton in her hand. The length of her arm is 0.5 meter. And the weight is 15 Newton. The weight of the arm may be assumed to add 0.2 meter from the shoulder. Calculate the total torque produced by the load above her shoulder if her arm is stretched horizontally. So this means that if the arm horizontally, this means that look at the arm. Let's say the arm is like that. So this means that is 90 degree. Hold an object. Okay, the object of 20 Newton and the arm with the weight of 15 Newton, right? 15 Newton, let's say this is the weight of the arm, 15 Newton. Weight is at on 0.5 meter. The length of an arm is 0.5 meter. That means that the distance from here to here, the distance is equal to 0.5 meter. And this is the weight of the arm. the width of the arm always at the center of the arm. Center of the arm, this means that equal to how much? So that means that may assume to be at, okay, so they said that the width of the arm is at on 0.2 meter. That means from here to here, the distance is equal to 0.2 meter. The question is, what is the total? Calculate the total torque. A. Total torque, that means equal to R1 F1 plus with R2 F2. So R1, let's say 0.5, 0.5 times 20 plus with 0.2 times 15. So at the end, we get that it will be equal to how much? Okay, this will be equal to 13 Newton meter. So this is the answer for A. Okay, get it? Now, if stretch, if the arms is stretched and at an angle of 60 degrees below the horizontal. Below the horizontal, this means I use a green color, yeah. That means that the arm stretched until like that, holding the object like that. Okay, so now below the horizontal with 60 degree. So let me share to the words. Okay, let's move to the words file. Okay, now let's say our arm now. This is our arm, right? Holding the object like that with a distance of 60 degree below the horizon. So now this object still with 20 Newton is going down and the arms of 15 Newton. Same, the distance still equal to 0.2. The distance from here to here is 0.2 meter and the distance from here to here will be equal to 0.5 meter. Ladies and gentlemen, now we need to change the force, the arms. Let's say the arms now is in this direction, where this is the 20 Newton and 15 Newton. Okay. What we need to do, we want to convert. Either you resolve the amps or you resource the force. No matter how, final, we wish to get the distance of the arm, the area, the radius, together with the force. The 20 Newton, and also that means that we want the 20 Newton and 15 Newton at the end at right angle. So what will be the angle here? This will be 60 degree. If 60 degree, that means that this will be the angle of how much? This one 90, right? This will be 30 degree, and this will be 30 degree as well. Okay, we can solve it, that means without change the force, or I can use the concept. What I do, I change it, I remain the distance. I remain the arm like that, but I resolve the force. I resolve the two forces. I resolve the two forces in this direction. That means this is 20 Newton, this is 15 Newton, where it is 90 degree. If I wish to convert like that, that means that I change the R. This one, I change the F. I resolve the F with an angle of how much? That means that you look at here, if the angle is like that, right? This is the F. I want to make it become like that. This is what I want. So that means this is 30 degree, right? So this will be F sin 30. Okay. If for this one, it's like that, right? I want to convert it. This is the R. I want to convert it to R X. This is the distance of R X. Here will be the angle of 60. So Rx is equal to R cos 60. That means that this one, I want to convert like that. I use R cos 60. No matter how, you see, one is using sin 30, another one use cos 60. Actually, class, at the end, the top, I can write that is equal to RF sin 30, or top equal to RF cos 60. Macam sama je, right? RF. Why? Because that it proves that sin 30 actually is equal to 660. So no matter how here, now if I want to convert, either use R1, that means that I want to find the total top, right? So the total top basic concept will be equal to R1 F1 plus with R2 F2. Okay, you want to use sin or use sin 30, sin 30, or you want to use find the total top equal to R1 F1 cos 60 plus with R2 F2 cos 60 will do. Or you can, okay, don't make any problem now. Just like that, enough. So both of them will do. Okay, either you use sin or cos. If I use cos, that means that I resolve the R. The R not in 90 degree, I resolve it into horizontal component. If I use sin 30, that means that I resolve the F so that the F and the arm will be perpendicular to each other. So from here, that means that we can use either one. So that means total torque, let's say I use the sin 30. Okay. R1 will be equal to 0.5 times with F1 is 20 Newton sin 30 degree plus with R2 is equal to 0.2 times with 15 sin 30. At the end, I will get that it will be 5.0 plus with 1.5. So it will be 6.5 Newton meter. So this will be the top of the arm, the object on the arm. Get it? Okay, let's go to the question C. Question C, if her arm is by her side. If her arm is by her side, what is the meaning by her side? If the arm by her side, that means that the arm like that, the object hold like that. Okay, so that means that this will be the 20 Newton, right? The 15 Newton now in this direction, 15 Newton. The distance here to here still 0. Okay, 0. How much just now? 0.2 meter. And here to here still equal to 0.5 meter. Total equal to R1 F1 plus with R2 F2. Okay, if this is sin now, angle, they are in the same direction. That means sin, the difference in the angle is 0 degree. Sin 0 degree. So this means that it will be sin 0 becomes 0. That means 0 plus 0. At the end, it will be equal to 0 Newton meter. The total torque will be equal to 0 Newton meter. Reason? Because the R and the F are in parallel and not are not in perpendicular direction. Okay, next question. Next question will solve the question where the object is in equilibrium state. Now we look at here. A uniform rod of length 2 meter and weight of 50 Newton is pivot freely. Pivot, that means this is a pivot. Freely about the point at the point O. Where is the O? Okay, ladies and gentlemen, the O should not be here. Please help me do the correction. Erase the O and write the O here. Here will be the O. Okay. Force of 50 Newton and 200 Newton act on opposite end of the rod as shown in the diagram. So 50 Newton and 200 Newton, both of them are at the opposite end. This means at each end. So calculate the resultant torque about O. Okay, B, state whether the system is in static equilibrium. Static equilibrium, that means not moving. Okay, static means that 0 ms-1 and equilibrium, that means balance. So calculate the normal reaction at the pivot. What is the normal reaction? Let's move through the words file. Okay, ladies and gentlemen, let's say I need to draw a diagram. The distance from here to here. Okay, and don't forget this, the width of the rod. Is it mentioned the width of the rod? The width of the rod is 50 Newton. Okay, so 50 Newton, what is the total length? They said that total length is equal to 0.2 meter, right? If the total length is 0.2 meter, that means that at the distance of half. Okay, so okay, let's say it like that. This will be equal to 1 meter each, right? And if this is 1 meter, 1 meter, 0.5 meter, that means that the weight of the object, where is my arrow? The weight of the object will be weight downwards. Okay, how much of the weight? The weight will be equal to W equal to 50 Newton. Okay, so this means that what is the distance of 50 Newton from the pivot? That's in 1 meter. From the pivot, it will be equal to how much? 0.5 meter, right? Here will be 1 meter. Now, they said that there will be 2 forces. is add on the both end. Two forces add on the both end with the magnitude of the forces which are 50 Newton and 200 Newton each. According to the question wants us to find the normal reaction. That means that the normal reaction will be add on the pivot. Okay, add on the pivot. Let's say I change the color. Normal reaction is R. So how much of the R? So after we analysis all the question, all the forces and all the direction, first, so that means that we said that the total top actually is like that. We look at the question. dimension that the diagram. This question said that the weight of 50 Newton and also the weight of 50 Newton both are at the same side and in the same direction. So that means that this 50 Newton will produce a torque in this direction. This one also in this direction. That means this will be anti-clockwise. For this 200 Newton will produce the moment in this direction. Okay, this will be clockwise moment. So let's say if this side is positive, this side is negative. So that means that we said that the total torque at O, that means that it will be total clockwise moment plus with the total anti-clockwise moment is equal to how much? If I make it like that, if I get certain, that means that this will be in this direction is positive, this direction is negative, right? This is positive, this is negative, right? If I get that the total with the value of positive, that means that the resultant moment will be in this direction. If I get that it's negative, that means that the resultant moment will be in this direction. But now if get that is 0 Newton meter, that means it's in equilibrium. Okay, so this means that it will be static equilibrium. So it's yes, static equilibrium. So now if we wish to find out the R, okay, so this one we add a sentence. That means that we can set that the total okay, so total clockwise moment plus with total anti-clockwise moment. So it will be, okay, equal to how much? So this means that anti-clockwise, okay, clockwise, anti-clockwise, one is positive, one is negative because opposite direction. So 3